All right, what's going on, guys? Today we're going to be talking more about building our knowledge for stochastic fields. Okay, but in order to do this, we need to really get probability under our belt. So we're going to cover a couple of probability videos within the next few weeks here, and then we're going to get into stochastics and all that fun stuff. Okay, before we get into the topic, make sure to hit that like and subscribe button. Make sure to go into my Patreon page if you want to support the channel. Make sure the more you guys contribute to this channel, the more I'll be able to drain the sound out from the dog. The more I'll be able to get higher quality stuff. And the aim here really is to build a business out of this idea. The idea is, there's a lot of people out there who really long for an understanding of advanced science. Right, like advanced general relativity, advanced chemistry, and all this stuff. But what we've been seeing so far on YouTube and all and other online educational platforms is an intro to the stuff, and then you're sort of left with, if you want to know more about more advanced stuff, you have to find this weird, obscure video on YouTube of some Indian professor maybe, or some non-English speaking professor teaching something, and it's hard to make out what they're saying. The quality of the video is bad. Really, the idea here is not just me trying to get content out to you guys. It's me really actually wanting to build a business out of advanced stuff taught to you in ways that's easy to understand. And so the more you contribute to this channel, the more I can get to that goal. But yeah, so let's jump into this, right? So also you'll notice I have the lever arm now to hopefully get my voice closer to the mic so that you can hear me a little bit better. So we want to be able to understand probability, okay? Maybe you know on probability already, but I would be remiss if I didn't talk about this before we started talking about stochastic fields. So in probability theory, let's ask the question: what's the probability, for example, of rolling the number of the devil, right? Within our system, within our one dice system, okay? The number of the devil being 666. Post Halloween vibes, I guess. So we roll the dice. This is how I like to think about it. You roll the dice. Each one of these outcomes has a 1/6 chance of occurring. Or each one of these states, you can think of them as, has a 1/6 chance of occurring, assuming, again, the sides of the dice are all fair. One side of the dice isn't weighted heavily than the other. Assuming it's all fair, then we have a 1/6 chance. Okay. And then we roll the dice again. We have a 1/6 chance. We roll the dice again. We have a 1/6 chance. So the total probability is 1/6 times 1/6 times 1/6, which is 1/6 cubed. If you want to do that, that's 1/216, or 0.5%. I'd have to double check that, but the point here is that this is the exact form. It's 1/6 to the 6 cubed. Suppose now we want to calculate the probability is, or what the probability is, for rolling 3 dice with the sum of all 3 dice being equal to or less than 4. Okay, so this requires us to say, okay, well, we have this possibility, which is 333. This possibility here, which is 1, or not 333, this is 1, 1, and 1, 1, 1, 2, 1, 2, 1, and 2, 1, 1. These guys here are all degenerate states of our system, meaning that in each one of these, we have 2 1s and 1 2. So the probability of having 2 1s and 1 2 is higher than the probability of having just 3 1s. That's another way of saying this, okay? But there's four of them, right? So this is going to be the probability of rolling a 1, right? Rolling a 1, and then probability of rolling a 1, and then probability of rolling a 1, okay? And this is really just going to be this guy here, right? Because we're just doing this here. It's just we're landing on different numbers. But we're doing it 4 times, right? Because it is we're rolling 3 dice with the sum of the dice all being equal to or less than 4. We're doing this 4 times, and so that is, that's why we get this 4, right? So we're doing this experiment. We're going to do it again, which is this experiment again, and so forth. That's where that 4 comes from. Again, my apologies for the dog. If you hear him barking, he's a Great Pyrenees. That's what he's bred to do, I think. We'll just push through it. So therefore, the probability of rolling the dice with the sum of all 3 dice being greater than 4, not greater than 4, less than 4. I don't know why I have greater than 4. Less than or equal to, right? Because we also had, these all add 4. Or, oh, I see what I did, right? This is greater than 4 is... Hey guys, what's going on? If you're interested in this video and want to learn more about loop quantum gravity, string theory, and so forth, what you can do is you can become a member of this channel and you can gain access to all the videos that become uploaded on this topic and future topics as well. Again, thank you so much for your support and thank you so much for watching. This channel keeps on growing and growing, and I'm very excited to see where this is going to go in the future. So with that being said, make sure to hit that like and subscribe button if you like this kind of content. Make sure to become a member as well. Thank you, and bye.